All right, hello, my wonderful students. This is Foldable Part 1 of Foldable number 3 for Section 6.2. Now we did multiplying, now we're dividing and simplifying radical expressions. So the first one we have here, we have these 4 problems to do, which are super amazing and awesome. So the cool thing is with this one that when you have the same index, we can rewrite everything under the same radical. So for an example here, we have the radical of 18x to the fifth divided by a radical x 2x cubed. So that means this can be rewritten, since they have the same index, as the square root of 18x to the fifth divided by 2x to the third, which is really, really awesome, because that means we can just rewrite this as 18 divided by 2, which is 9. Still under the square root, by the way. And whenever you have division of exponential values of the same base, so x, you can actually just subtract them. So this would be x to the 5 minus 3. So this ends up just being equal to the square root of 9x squared. Well, we know that 9 is just 3 times 3, right? So we can rewrite this as the square root of 3 squared x squared, which is just equal to 3x. Easy peasy pumpkin squeezies. All right. So the next one here, we have the cube root of 162 y to the fifth divided by the cube root of 3y squared. And once again, these both have index of 3. So we can combine them. Do this one in blue. So we can combine them together and leave it as 162 y to the fifth divided by 3y squared. Mental math powers. 162 divided by 3 would be 5, carry the 1, 12, 4, so it would be 54. And once again, we can subtract our power, since we have a base of y on the numerator and denominator. So we have y to the fifth minus 2 for the 2 down there. And you can actually see y. Little side note, if you had a y to the fifth and you're dividing it by y squared, this is just giving you 5 copies of y on top and 2 copies of y on bottom, which would, when you simplify, would reduce these by 2, so leaving you with 3, which is exactly what's going to happen here. But that's the reason why we could do that, just in case you guys forgot. All right, so now, remember, this is still cube root, Mr. Payan. So now we're going to go ahead and rewrite this again. We have equals to the cube root of 54y to the third, which is good sign for us. Now we're just going to figure out this 54. So I know 54 is good in green, so we didn't get too much blue, is 9 times 6. 9 is 3 times 3, and 6 is 3 times 2. So we got 3 2's, which is good. So we're going to write this as the cube root of 3 cubed times our 3 cubed as well. Then we can rewrite this with 2 equations. We have our, keep forgetting the cube root, not good. We have a cube root of 3 cubed times y cubed times our cube root of 2, which is what's left over. This is just going to leave us with a wonderful answer of 3y times the cube root of 2. Because the cube root of 3 is 3, and the cube root of y is this. 3 does not go with the y, it goes with the index for the cube root. The next two are relatively easy, and I'll show you why they're relatively easy right now. Because they have the same index, we can put them under the same radical. So we have the radical of 75, divided by 3. Well, 75 divided by 3, if I have 75 cents and I need to divide into 3, it's easy, it just makes 3/4. So this equals the square root of 25, which we all know to be 5. But if you didn't, you can see that 25 is 5 times 5, which would give us a square root of 5 squared, which would turn into that anyways. Okay. Last but not least, we have a last one, which is our square root of 6x divided by the square root of 3x. Because they both have the same index of square root, we can go ahead and write them all underneath the same. 6x divided by 3x. Right away, we can see that, the x and x can be simplified, but in the sake of using the right, math, we want to do it the right way first. So what we're going to do is we're going to do 6. So it's going to be equal to 6 divided by 3, which is 2. And then we're going to have x to the first power, because these are both to the first power, minus 1, because the 1 minus the 1. So this is going to give us equal to the square root of 2x to the 0. But anything x to the 0 power is anything to the 0 power is just going to be 1. So it's actually going to be 2 times 1. So it's going to be equal to the square root of 2. Final answer.